Hello everyone and welcome to the demonstration video. So this is going to be the last portion in which we cover object-oriented programming concepts. So the last couple of weeks, you're introduced to object-oriented programming. So what it is, how to use it in Java. The second concept, you learned about the different relationships between objects. So for instance, in today's example, we actually have a zoo. There we go. So we're going to implement just a mini application for a zoo. And of course, when we have a zoo, we have multiple animals. So we could go ahead, represent the zoo as its own class, and then the animals as their own separate classes. So we learned about that relationship between different objects or different classes, how you could create those relationships. Now, there's another formula you could think of as a relationship which we haven't gone over yet, and is probably one of the most important uses of classes or of object-oriented programming, and that's inheritance. So if you think about inheritance in the terms of, let's say, normal humans, whether biology or even monetary economy, that typically means you're lending down something. So when it comes to inheritance with biology, typically you'll have, there we go. Typically you have parents, hopefully you've been given this talk, but typically you have parents and the children will have some traits with those parents, whether by appearance or personality. There we go. So just know that, again, we inherit certain traits from our parents. We typically look like our biological parents because those genes were passed down. If you had someone in the family who's probably very creative, that would also be passed down to you. So there's that biological aspect. Also, there's just the aspect of if you have a very wealthy family member, or someone who's very wealthy, and then they die, but they have a will passing down their inheritance to someone. There we go. So money to someone else, then that other person gains either those properties and such. So we typically think of inheritance in that way. The same thing goes for classes. So in the case of here, so right now we are trying to do an application with the zoo. Of course, we need animals within our zoo. So if we have multiple animals in our zoo, depending on certain enclosures you have within there. But of course, we don't just have animals, we have multiple animals, and especially different types of them. If you're trying to do an application in which, even if it's just for the guests themselves or for your employees, animals are going to behave in different ways. In this case, we'll just focus on, let's just do maybe 2 or 3. So maybe we could go with something like we have giraffes. There we go. So right now, let's just implement 2 animals. So we have giraffes and we have lions. Obviously, 2 vastly different animals that can act very differently. And even if it comes to taking care of them, there's different ways to do that. However, they're both considered animals. They're both considered being a part of certain enclosures within a zoo. So inheritance by classes is basically looking at certain classes that have certain similarities. So in the case of animals, we definitely know that, in our zoo, we have multiple animals. They can have certain sounds. So maybe you want to imitate their sounds. You could go ahead and implement that. Maybe they will be let out into the enclosure. So you could say, maybe they get free time. Okay, maybe they get sleep time. They'll also eat. There we go. So they make sounds, they have some free time, so maybe they roam around. I guess I could call that roam. Here, let's get rid of that. Roam. There we go. So they could roam around, they could sleep, they could eat, they could drink. There we go. So we know that there's general things that occur with specific animals. So you could just implement this as such for an animals class, but of course, if it's something very specific, like let's say a giraffe versus a lion, how they act or how they're taken care of, that would be a little different. Like for instance, giraffes eat leaves, or at least some kind of shrubbery. You could think of it as just greens. We could call this greens if we want. While lions are more carnivorous, so if we want to have them eat or if we want to feed them, they'd need something that's a little more meaty. Of course, they have different sounds too. I'm actually not sure what sound a giraffe makes. Maybe we'll just kind of do it similar to a horse, like a neigh. And in lions, they will roar. Okay, so you notice that even though they're both animals and they can have similar things, even down to all of them having a certain name. And heck, let's even do an age. There we go. They still have other things like what they specifically eat, how they specifically sound. Maybe for a lion, they have a specific time in which, in their free time, you provide an activity for them to imitate hunting. While giraffes, maybe they have something else, or maybe they don't have any special activities at all. So when you're programming, these are different things in which you have to take into account. Especially if we just started with just giraffe and lions, we'd be copying much of the same code over here with the animals. But if we could get the animals class and just expand on it by adding in the stuff that makes it unique, then that's where things get a little different. Okay, so how exactly do we implement inheritance with this? So in the case of, like, if we create a specific giraffe object, how are we able to extract stuff from the animals object? So these specific ones related to animals, how do we extract it? Before I start coding, think of it a little more like a family tree. So in this case, know that when it comes to inheritance, so certain functions or traits you could pass down, think of it as a tree. And think of it as the age-old example where teachers tell you a square can be a rectangle, but a rectangle cannot be a square. If you haven't heard that before, I suggest you research that real quick. But just know, in the case of these hierarchies of classes with inheritance, animals, we know that it will encompass, I'm going to put G for giraffe, and an L for lion. Okay. So anything down here can inherit anything that's above it. Giraffe cannot inherit from lion because it isn't, as we call it, a child of animals. So it can only be anything that's above it, not at the same level or even on lower levels. Like in the case of lions, maybe you have different ones. I don't know of specific lions, but just know that maybe these will be different kinds of lions. And then maybe they have their specific activities, specific diets. But these lion classes, they can grab any attributes or functions related to this lion up here, so the general lion. They could also grab any attributes and functions related to animals. But again, they cannot get anything from giraffe, or giraffe cannot get anything from the lions or those lion children, because they're on different levels. Remember, they could only get stuff that's a level above them and not below them or on the same level. Okay. So let's take a look at our code here. I already set everything up. Let me go ahead and I'll flip through some of these files just in case if you want to pause and implement them real quick, you could go ahead and do so. So here I have the zoo.java. You could go ahead and take a look at this, but this is how we'll generally implement the zoo part of the application. Here's our zoo driver. So I gone ahead and just did a simple implementation with the zoo class. So ZooDriver.java, you could go ahead and implement this version. And as for animal, I've left this blank so far because that's what we'll be working on. Okay, so first, let's go back to zoo. Okay. So of course, our zoo is going to have a certain set of animals. So we could go ahead and add different animals. So here, let's go ahead and say, oh, we have a private, oh, there we go, private array list of animals. I just put animal because that's what the class is, animal.java. There we go. We just call the list animals. There we go. And then remember, every time we have the array list, we have to initialize it here within the instructor. So let's go ahead and do that. So animals, well, actually let's do this dot animals equals new array list. Oh, my bad. There we go. And I spelled that wrong. Perfect. And if I want to print out the info, I would go ahead down here. And since we want to print out the list of certain animals, we could go ahead for now. We're just going to do animals. And then just go through the list of animals. If not, here, let's do, whoop. So if animals empty, well, is empty, there we go. So remember, this is a function that you could use with array list, say if the function is empty or not. And if it is empty, you'll say no animals today. Sad face, there we go. And if it's not, this is where we have to start implementing the animal portion since we actually want to print parts of it out. Okay. So let's go ahead over here to animals and let's start implementing this. So we definitely know for each animal, they have a name. So we're going to go ahead and do public string name. So that's the literal name that was given to the specific animal. Let's also do an age by year. So public, actually, remember, I forgot, why am I doing this public? This is supposed to be private. Always remember the attributes we want to keep private. So private int age, remember this is by years. And let's go ahead and create the constructor. So public animal, we want the name to be passed in, so string name, and then the age to be passed in int age. And of course, we initialize this name equals the parameter name, and then this age is equal to the parameter age. All right. So if I just did this on its own, and let's go ahead and create a public print info, we could go ahead and just print out public void print info. We could just go ahead and print out the name and age. System.out println name is equal to this name. And of course the age is, remember, year. So age, this age, and we'll just add to the end years. All right. So now let's go ahead and run this real quick. And again, it says no animals because there isn't much animals to show. If we go ahead and implement the for each animal, so animal A in animals, There we go. And then just call the print function for each object. So print info. And then let's give it some space with the system.out print line with empty quotes. There we go. So now we could go ahead and we could just put in our own animals here. So let's do animal 1 equals new animal. Let's call this one Trixie. And then Trixie is 3 years old. But notice we don't know the specific type that Trixie is. So if I run this, actually notice we've gone ahead and created a new animal, but actually we haven't created something to add to the list. So let's go ahead, let's have a specific add function. So remember, this is why you want to plan stuff ahead first, because there's specific functions you do have to add. So let's go ahead and do public void add animal. And of course, since this is a function, we could just add in the animal here. So animal, let's just call them A. And we just go ahead to animals dot add, or in this case here, we could just either do add A. There we go. So now we could have Trixie. Let's do my zoo add this new animal. Add animal A. I keep forgetting it's not A. Let's go ahead. Boop. There we go. And we could see that Trixie's here. We see Trixie's age. We could add another animal. Maybe this one's Pablo. Age 10. There we go. Run this. Perfect. So we have a Trixie, we have a Pablo, we know their ages, but we don't know exactly what kind of animal they are. We can't really say that, hey, this is a lion or giraffe, because they're just animals. Some people would go ahead and implement like maybe a specific variable for type, so private string type, and we could always add giraffe and lion to it. But remember, there's a whole set of features we want to implement with each one. For example, for animals, they have specific things they can do, but there's specifics to, let's say, a giraffe or lions. So at least in here, if we want to expand upon animals, let's go ahead and create new classes for giraffes and lions. So let's go ahead to this package, right click, new class, and this one will be giraffe. And let's do the same thing for lion. All right. Now, right now we're just going to work with the very basics of animal, but do know that here we want to go ahead and implement still some of these functions that are consistent with animals, but they're different based on whether it's a giraffe or lion. There is a specific way to go about that, and I will show you. So in some cases where you want to implement functions that you know will be added on or changed by future classes, so future children, like in this case giraffe or lion, we would go ahead, we call this abstract functions, and all you have to do is add the word abstract in front of it, and then you could start it out. In this case, since we want to do, let's say, eat or feed, so abstract private, let's call this public void feed. Perfect. So you just add the abstract here. And of course, if you want to use abstract functions, I'll explain that just in a moment, but just know, let's go ahead up here and add abstract to the class itself. So one, this is considered an abstract class. This means that animal is going to have stuff that is branched off of it. So this is a base class. You can think of it as a base class that is supposed to have special classes attached from it. So branching off from it, like in this case, a giraffe or lion. If you want to add in more animals, we could do that. But we know that at least for each instance of this class, we definitely know that one, they need to be fed. So they need to be feed. So we need the feed function. And let's see something else we could do here. They could just go ahead and sleep, or they could do a sound. So I'll go ahead, create another abstract one for sound. And then for sleep, we could just go ahead and just implement this here, since maybe there isn't any specifics to specific animals sleeping. So we could just go ahead and do the name is sleeping now. Okay. But again, these two abstract functions, they're created. It just gives an indication to the programmer that, hey, if we're going to create a new animal, they need to do these two things. One, they need a way to be fed, so feed them. And then two, they will create a sound. Now, if I'm a programmer looking at this and okay, I want to implement giraffe, first things first, always at the top of your class header, so outside of your braces, after the name of the class giraffe, you're going to put in extends animal. So this means that we're going to be using stuff from the animal class. So we're inheriting these attributes and these specific functions into this class. So let's go ahead. We're going to go ahead and create a constructor, which is why it's a little angry here. So public giraffe. We still want to pass in the name. And let's do int age. So same thing as the previous constructor, but notice we don't have to exactly do this again, especially since these attributes, we could still access from giraffe. But something else we can do is we could use something called super and then just pass in the name and the age. And notice that the IDE is doing that for me. There we go. So what this will do is it will go ahead and it's going to, whenever we call super within a certain function, in this case it's within the constructor, this is going to call it from the parent function version. So it's actually calling this constructor animal, passing in the name and age, and if we want to set up anything else, like in here, maybe we do want a string type. Private string type. Then we would go ahead and pass in that type. So we would go ahead and say, hey, this type is giraffe, or actually, let's go ahead and just implement that here with the animal. So specific type of animal. So when we go to this constructor, string type, and then let's do this type equals the parameter type. Then from here in giraffe, all I have to do is just pass in giraffe. So every time we create a new giraffe, it will go ahead and just pass in the type as giraffe. So when I go ahead and print out the info, type this type, then it would go ahead and do it accordingly. Okay. Now the thing is, it's also still a little ingress because remember we have abstract functions that we need to implement, and to do that we just implement them like normal. Okay. So we have public void feed, and let's just go ahead and feed this animal with a print statement. We could just think of it as a print statement. There we go. And notice that we can't get the name because it is private up here. So you would still need to go ahead and implement some function to grab things like the name and the age. So let's go ahead and do that. So remember, if we want to pass it a name, we'll just do public string get name, return this name. And now since this is public, then we could go ahead and say, hey, this dot get name. And notice that this is happier with it because we went ahead and created a public way to get the name. So remember, private and public still work when it comes to base functions, so parent functions and their children. Just make sure that you provide the needed functions to be able to access those. Okay, and of course we have a specific sound. So in this case of a sound, well, remember you don't have to add an abstract. You just go ahead and implement it, and then now notice that the function feels better because we implemented the needed functions we dictated. So again, we mentioned, hey, an animal, they're going to make a sound, they need to be fed. Now we've implemented that here. Let's go ahead and go nay nay. Let's just do nay. There we go. And I almost forgot to in the feed here this name. So is eating the trees. There we go. Perfect. So now I could go ahead and implement specific giraffe. So let's go ahead over here. Whoop. So let's just mess around with our giraffe for a bit. And I'm just going to dictate them with a GRI. There we go. And so notice we could create a new giraffe. Whoop. Like so. Okay. And again, see how an animal, notice that this has 3 parameters. We're still able to do giraffe here with just 2. Let me go ahead and comment this out. There we go. But because we're always passing in giraffe here. Okay. So we did giraffe. Notice that if I do still do giraffe print info, it will go ahead and still run that. So there we go. We have perfect. Let me comment this out for the zoo print info. And notice, oh, we did some weird formatting with the type. But notice that even though print info isn't created within here, it's being used from the animal class it extends off of in print info because this is public. So let me write that down real quick so you know that. That functions and attributes can be inherited down if, 1, obviously the class is a child of the parent. So that means it extends. And then 2, that attribute or function has to be public. So keep that in mind. If you cannot get something from a child class, make sure that 1, it's still being extended from that base class, and then 2, that function or attribute is public. If not, you may have to create a function, just like how we did with the get name. There we go, the get name, which is public and can be utilized. Okay, so notice, there we go. Let me run this again until we get perfect. So we have Trixie, and Trixie is giraffe, oh, not giraffe years. Hold on, let's go ahead and let's edit that. There we go. Trixie is just type giraffe and an age 3 years. Now you may be wondering, okay, Miss Ojeda, we've gone ahead and implemented giraffe, and let's do it real quick for lion. So remember, go ahead real quick and try to implement a lion version. And once you're back, let me go ahead and go through it real quick. So again, we want the extends. So don't forget that extends. Perfect. And let me just copy and paste all of this. Since it's going to work very similarly, we just have to tweak some things here and there. Okay. So instead of giraffe, remember, it's a lion. The type itself is lion. And then this get name, the lion is given a pound of meat. And of course, the lions go roar. There we go. And again, we mentioned that, hey, what if we had a specific function for the lion wanting to hunt something? So let's go ahead, create something for the lion, and then we could go ahead and maybe put in a specific name of an animal in which it's hunting, and we could say that, hey, this name, so get this name, is hunting that specific animal. Okay. So you see how I just changed up some quick things. We've gone ahead. I didn't have to recreate everything here from animal. I don't even have to recreate the print info or the sleep. I just go ahead and add on top of that. So now I could do the same thing for lion. So instead we're creating a lion, I'm going to do this as, well, let's just call it lion. This is giraffe. Giraffe. There we go. Lion is, we'll just call him Leo. Maybe Leo is a grand old 10 years old. And Leo, we could print the, well, for Leo, we could print the info. Oh, and notice, there we go. That's giving issues because remember, we're creating a new lion class. So lion, we could print the info, and then we could also have the lion hunt. And we want the lion to hunt, maybe let's have them hunt a mouse or a rabbit. Let's do a rabbit. So now if we run this, there we go. So we print out the name for giraffe, and notice, there we go, it gives the type giraffe, age in 3 years. Same thing with lion, but instead it's Leo, lion 10 years, and Leo's hunting the rabbit. Notice that I can't do giraffe.hunt fish, because we never implemented that. This will not run. Okay. So those are specific abstract classes. So remember, it kept giving us errors until we implemented these classes. So again, this is the base in which you could tell certain programmers, hey, this needs to be implemented for this to be considered finished. Okay. Now, one other thing I do want to show. So notice that we still need to implement our animals classes. Oop. And remember, we mentioned that, okay, well, we have a list of animals, but we have giraffes and lions specifically. Miss Ojeda, do I need to create a list specifically for lions and giraffes? No, you actually don't have to. And that is because of polymorphism. Okay. So in inheritance, you have something called polymorphism, which basically, just like the example that I was saying earlier of, hey, a square is considered a rectangle. It could still be considered a rectangle. Remember, a rectangle, all it needs is at least 4 sides and 4 right angles. When it comes to a rectangle, it doesn't matter if the sides are all the same size. It just needs 4 sides, 4 right angles. Now, a square, it has to have all the same sides and all right angles. So this is a lot more specific specifications as compared to a rectangle. But notice that a square can be still considered a rectangle because, again, it still has 4 sides. It still has for right angles. Therefore, a square can be still seen as a rectangle. Now, rectangle cannot be a square. Again, because squares need to have all the same size. So all the sides need to be the same length. Notice that when it comes to a rectangle, two sides are typically longer than the other two. Therefore, it cannot be a square. So remember how we mentioned with this hierarchy here with animals? This is how kind of polymorphism works. So basically, remember, a giraffe and lion are still animals. If you want to utilize a list, like in our case, we're just printing out the information, you could still go ahead and do that. You could go ahead and just create a list, do basic functions with each of them, as long as you still call them all animals. So giraffe and lion are animals. What you cannot do is create a list of giraffes and then try to put in lions or animals into there. Why? Because this list is specific for the usage of giraffe functions. Java will assume that, hey, you're trying to put in this specific size in here. So you could think of it as trying to stuff in. So again, imagine this box as your list of animals, but animals box is like this size. You can't shove that in here. So just think of it that way. But polymorphism, remember, this is the base version. So you could have a list of animals, put in different kinds of animals, whether it descends from giraffe, lion. Heck, if you create a new one for penguins, you could put that within the list, as long as you're still somewhat utilizing this basic functions. If you want to do something specialized, that's why we have something here like the type, that in which we could check and then perform specific functions with it. Okay, but for now, let's go ahead here and let's just go ahead and add our giraffe and lion to the list. So let's go ahead and delete these. There we go. We could go ahead and delete this now. MyZoo prints info, and remember, we still have to add stuff to MyZoo. So all we got to do is MyZoo dot add animal, and notice I could pass in giraffe because it's still considered an animal. Remember, giraffe descends from animal, therefore it is still seen as animal. I could go ahead and put in the lion. There we go, because it is also extending from the animal class. And so if I run the zoo print info, you see that now we have our zoo. We have the animals, and you notice that we print out everything from Trixie, giraffe, 3 years, and Leo. If I want to do something, let's do a function where so kind of this same function, but instead we're going to call it feed animals. Okay, there we go. And then here, if it's empty, there's no animals to feed. If it's not empty, we will go ahead and print everything, but in this case, we're going to go ahead and instead of print info, we're going to feed them. And we don't need spaces in between. So now notice if we do MyZoo, and we want this, there we go, it's feed animals. Feed animals. Then if I run this, so now we get the info of the zoo with the animals, and then notice that they have different functions for feeding. Trixie is eating the trees. Leo is given a pound of meat, because remember we had to implement that for both animals. If we want them to make noises, make some noise. Again, no animals, sad face. Or a.sound, there we go, So now let's go ahead and do the make some noise. And before we do that, let's go ahead and add in a space in between so we can see the difference. System.out.println. Perfect. So if I run this, there you go. You see even the noises are different, but it's because, remember, the animals are different. So now we have Trixie, Leo. Trixie's eating the trees. Leo's given a pound of neigh and roar. And I notice this keeps on changing if we add different animals. So if we want a lion named Nala, 7 years old. Oh, let's do this lion 2. Whoop. Lion 2. Let's go ahead and add lion 2. There we go. So now if I run this, there you go. Now we have a new lion named Nala, 7 years old. Nala is given a pound of meat, and Nala also roars. So those are different things you can do with polymorphism and inheritance. This kind of saves you time because, again, I don't have to implement all of this again for giraffe. I don't have to implement all of this again for lion. If I need something that's general for all animals, I could implement it here. If I need something specific for giraffe, or in this case, if I want to add more stuff like hunting for lions, maybe if we have a specific show for lions, we could go ahead and implement that here. That's very doable. I don't have to keep track of everything here. I mean, you still have to keep track of it, but it's a lot more manageable when you compartmentalize everything. And then also just keep it encapsulated. It's all the animals, and then just branch off what you need. Now, if you do need something very specific, so in this case, maybe let's go ahead and implement a function where we put animals to sleep. There we go. So we want to put the whole entire zoo to sleep. So if we do that, let's do the same here, but instead for sleep, there we go. Okay, so if we put everyone to sleep, we notice that, hey, everyone's going to sleep. Trixie's sleeping now, Leo's sleeping now, Nala is sleeping now. If we want something very specific, so maybe for a specific giraffe, we want them to sleep a little differently than what's indicated here. If I try implementing my own sleep class, and I want to put in something different, so the name of the giraffe is sleeping, standing up. There we go. And remember, we want to do is get this name. Perfect. So let's see what happens when we have this run. There we go. So still we'll go ahead and do Trixie is sleeping, standing up. Sometimes you may get an error which doesn't allow you to do what we call override. So notice that here we implemented a specialized version of the class. If the parent class, so if this animal class has a function very similar to it, so in this case again it's sleep, but we're trying to call it for the specialized function, so here's sleep, it will go ahead and call the specialized version. If it doesn't do that, so sometimes Java can be a little nitpicky, and it will maybe just call this generalized version, you can go ahead and use the override function, which all that is you do @override, there we go. And it would go ahead and just implement this version, especially if you want them to maybe string, like have them sleep in a certain way. There we go. So again, you may have to do the override function if you needed to have a different functionality. Sometimes you have to use a certain override function when it comes to, let's say, specific functions already implemented with Java. Like you may have come across the toString function, which will go ahead and kind of turn the class itself to a string, kind of like how you implement the print function. But that has its own functionality. Sometimes that's set in stone by Java. If you do want to override it, so in this case, change its functionality, you would have to go ahead and do the override here. And that's all you have to do, override. Of course, if you always want them to have a sleep function, again, create an abstract class of it. This, as you saw, it specifically shows that, hey, this class is not complete unless you implement any of these abstract classes. Okay? But I'll leave it there. This is something you could really mess around with, especially when it comes to trying to compare two separate lines. Like in this case, if I do, let me show you guys something real quick. Let's edit all of this out. So especially when it comes to trying to, here, let's do a print, well, system print. System out print line. And remember, there are certain logical functions which you could do, like, hey, the 0 equal to a certain integer a and such, but we could do the same for functions. But if I want to say lion equals lion 2, this should come out as true or false. So notice, hey, this line should be different from the other line because they have different names and different ages. So if I run this, there we go. Notice that it is false. In some cases, you can go ahead, it will go ahead and see, hey, are those specific things equal to each other? Let's go ahead and do lion dot equals line 2. There we go. This is another way in which you compare classes. Let's go ahead and run this. And it does show as false. If you need some specific way to say if something is equal to each other, in this case, maybe equals means, hey, are they the same type? You have to go ahead and implement this on your own. Maybe in the case of zoo, let's go ahead and do this real quick. So this will return a Boolean. So public Boolean, this is going to be equals. And we're going to pass in an animal. And we're going to return this. Well, actually, let's go ahead and do a get type. Oh, wait, my bad. This is the wrong class. Let's go ahead. Not for zoo. For zoo, this is fine. We wanted to compare different animals, and we're going to do that within this animal class. There we go. And to do that, we need a public string to get the type. So get type. There we go. So now return, and we're going to say if a.get type equals this type. All right. So now since we specified it that, hey, this lion should be equal to this other lion, because we want the equals to mean, is it the same type of animal? So we've indicated here with the equals, hey, it has to match by the type. We specified specifically by the type. So let's go ahead and run this, and now it says true. So notice if I take this out, let me comment this out. There we go, and I run this again, it returns as false. I put it back in, it's true again. If I want to go back to just using equal sign, notice that comes out as false because it's not a specialized function. There's a way in which you could still indicate that, hey, this will be treated differently, but it's a bit of a longer process. You can look at it. But just know that you can go ahead and create functions like that, especially if you want to say, hey, lion is equal to this lion. Lion is not equal to giraffe, so this should indicate false. There we go. Let me go ahead, let me do lion 2. There we go. So this should come out as true because they're both lions. This one comes as false because the lion does not equal a giraffe. So again, those are different ways in which you can have associations with specific objects when it comes to inheritance. All right, so remember, this is your base class. This is what all of the objects below you are going to inherit. Down to, there we go, so the specific constructor. So what the name associated to it is, age, type, general things such as info, sleep. We have some helper functions, mutator functions, not mutator, selector, get name, get type. We have some abstract ones which have to be implemented here, and of course we could add on if we need or alter existing functions. So just make sure, again, with these, notice how this was a little all over the place because we didn't fully plan it out. So just make sure you're planning out, one, what functions you need in general for all animals, or again, the base here. And then what is specific to things, like two things that are branching out of it, like in this case, giraffe and lions, what makes it different, what do you need to add on to those classes. All right, I'll leave that there. Again, if you need any assistance, please make sure you're contacting me or checking out the student hours. All right, I'll see you in the next video.